this. So till yesterday we completed till over here, isn't it? Like how to write the time period equation, basically in case of SHM and all, how we followed that. So the day before yesterday, means day before yesterday, we dealt with how to write the time period equation using the force equations, isn't it? Now we'll try to learn means we'll try to understand how to write even through the energy equations. Got it or not? And then we'll move ahead. Okay. So the many things we did. Now let us just focus on that. But before that, I'll try to have a recap of whatever thing is there, isn't it? Okay. Let me just uh, check whether it's working or not. Mm, yeah. Okay. So let us start this. Right or not? So we'll go through the question wise question. We'll learn through, understand through the help of the some of the questions, and then we'll move ahead. So let's just have how we did that. Means what were the steps? First step was basically check for the force equations for the equilibrium. ठीक है ना? हम क्या कर रहे थे? पहले इक्विलिब्रियम पोजीशन निकाल रहे थे, है ना? पहले इक्विलिब्रियम पॉइंट निकाले थे, फिर उसके बाद इक्विलिब्रियम पॉइंट निकालने के बाद मींस व्हाट वी डिड, लाइक फॉर दिस इक्विलिब्रियम पॉइंट वी रोट द इक्वेशन, देन यूजिंग दैट इक्विलिब्रियम पॉइंट वी डिफाइन where this velocity will go zero, and based on that, using the force equation, F is equal to minus of omega square x, sorry, acceleration is equal to minus of omega square x. We try to bring this form, isn't it? And after bringing this form, we wrote the time period equation. Got it or not? Okay, so we'll try to do similar thing over here. Let us just try to cover it fast. What it is saying, there is a block of mass m, which is means thrown out, or which is just made to collide to this block. And what happens is the collision between these two blocks is inelastic in nature. What is the nature? Acha, what is that meaning of that? Means it's given over there that it perfectly sticks to it. So इसका मतलब है कि this is a perfectly inelastic collision. Which kind of collision? Is that clear or not? So this is my perfectly inelastic collision. The block collides and sticks to it. The question is find the amplitude of the resulting simple harmonic motion. Is that clear or not? Okay, so just try to do it and then I'll move ahead. Okay, you have 2 minutes of time. Okay. Try this, then I'll definitely help you in this. Okay, just try this first. Okay, let us have this. The point is, what it is saying, that this is my one of the block. Okay, this is my one of the block which was moving with velocity v. This block at that instant of time was at rest. Now the collision happens between them, and these two blocks sticks together. Then the total mass will be 2m or not. But the final velocity will be totally different. Let us call that final velocity to be Vf. Okay, means I call that final velocity to be how much? Vf. Good evening, Riva. Okay, is that clear or not? Okay. So when the final velocity is Vf, I have these two blocks. Now we know that. First of all, you tell me, is there any kind of external force acting on the system initially? No, no. No. So, and even if you see that when the spring force starts to act, the net spring force is also zero. So the net external force on the whole system is how much? Still zero. Is that clear or not? So when net external force is zero, we know that the momentum will remain conserved. Means the change in momentum should also be equal to zero or not. Meaning of that is the whatever is my initial momentum, that must be equal to final momentum. Is that clear? Now, if you look into the initial momentum case, the block M has velocity v, so m into v, plus the second block has zero velocity, so m into 0 must be equal to two blocks stick together and they start to move with some velocity. So I have the equation 2m and its velocity I call it as v final. What is its velocity? Now you look over here. If you know the v final, then particularly know what will be that mv divided by 2mv, 2m, mm cancel. So what is that? V by 2. So after sticking together, they start to move with half of the original velocity. Is that clear or not? ठीक है, तो मतलब हम बोल सकते हैं कि दिस इज माय कॉमन वेलोसिटी आफ्टर कोलिजन. मेरी बातें समझ में आ रही हैं? What is it required? Yeah. No. Okay, just right for right now, you just think that it's not required over here. After completion of this SHM and waves, I'll take your collision class, right or not, and then I'll teach you how to do that. Okay, means at the same time we'll do that. Do not take tension. Okay. So we'll take the collision class. Means two classes I'll take, and I'll try to finish it off fast. Okay. ठीक है ना. तो ध्यान से देखो, तो कॉमन वेलोसिटी आफ्टर द कोलिजन इज हाउ मच? v by 2. मेरी बातें समझ में आ रही हैं? Now, when you have common velocity after collision as v by 2, what actually happens? Let us see that. Now, what is the meaning of amplitude? Just try to see. I'll try to picturize this. Means I'll try to show you this SSM. Right now, this both of the blocks 2m currently has a velocity how much? v by 2. Yeah. So amplitude is that particular length over where it is the length between the maximum velocity and zero velocity or not. So wherever this velocity becomes zero, that is my condition for which case? The condition of the length between that particular velocities is going to be called as amplitude. मेरी बातें समझ में आ रही हैं नहीं आ रही? ठीक. तो अब एक बात बताओ, अगर हमें अगर किसी भी, ध्यान से समझना जरा, अगर कोई भी ऑब्जेक्ट है, अगर कोई भी ऑब्जेक्ट एसएसएम कर रहा है, इफ एनी काइंड ऑफ ऑब्जेक्ट इज डूइंग एसएसएम, then we know that its total energy is always same, isn't it? Why I'm writing total energy to be same? Because there is nothing told about the spring, how this spring is working or something like that. Or you can even write the total spring equation. मेरी बातें समझ में आ रही हैं? ठीक. Now look over here. You try to understand. Wherever the velocity will be zero, if this is my spring, how it will be zero? Let us first try to picturize that. We'll do it in a good way. Don't take tension. ठीक. So let us suppose that this is my block. Okay. I have the spring attached. Okay. Now, when the blocks will combine, when the blocks will have 2m mass, at that time it has velocity how much? v by 2. But the spring will be at its natural length or not? ठीक है ना? Yeah. Okay. Now, from here, what will happen? Suddenly, a time will come since there is no external force. So, can we treat this as equilibrium point also? Yeah. Basically, the velocity is imparted. No acceleration is provided. So, this is my also an equilibrium point. Which kind of point? Now, what will happen? This block will start sliding and it will compress the spring. This block will come somewhere over here, and the spring will get compressed due to that. है ना? So this point where this velocity becomes zero will have a certain gap between this point to this point, and that is my the gap of maximum compression, or you can say the maximum compression length, which we also denote it by the amplitude or. Then consider this as initial point and consider this as final point and apply the energy conservation. Why? because all the forces acting over here are conservative in nature. कैसा है स्प्रिंग फोर्स कंजर्वेटिव होता है या नहीं होता? तो whatever is my total energy initial must be equal to total energy final. What is my total energy initial? Half mass is 2m and velocity is how much? V by 2 whole square or not? At that time spring potential energy will be how much? 0 or not? What is total energy? Kinetic energy plus spring potential energy this time. Okay, that is initial must be equal to kinetic energy plus spring potential energy final. Is that clear? Now, what is my final kinetic energy? It's 0 or not? What is my spring potential energy final? Half k. X max is equal to amplitude, so half k square. मेरी बात समझ में आई? So what you got as your amplitude? Look over here. You got your amplitude or not? That is. What is spring potential energy? Half kx square. For the case of maximum expansion, this x is the length. X is what? Displacement from the equilibrium point or not? How much we are displacing? We are displacing equal to amplitude. Yeah, so 2 cancel. This is mv square by 4 is equal to half ka square. 2 cancel. So what I am left with a as? A is equal to root under how much is that? That is mv square by k. That is v root under m by k. So this is my, yeah, there is 2 also now. So okay, yeah. So amplitude is how much? V root under m by 2k. Is that clear or not? That's my amplitude of the equation or the amplitude of SHF. Is that clear? Understood? Now, based upon that, you can do any kind of thing, any kind of equation. If you know the amplitude, then you can also write the time equation or time period of the oscillation, isn't it? Look over there. What will be its time period? Simple. Omega, how many masses are moving? Omega is equal to, simple. How many masses are moving? 2m mass is moving or not? So the time period is just 2m by root under 2m by k. Omega is equal to root under 2m by k. Is that clear? Time period we can write 2 pi by t is equal to root under 2m by k. Okay? Okay then. Let us just solve the next one. Try to do this. बोल रहा है a system is in equilibrium in such a way 1 minute. A system is in equilibrium in such a way and it is at rest. Okay, बोल रहा है this is my initial system. Okay, and I remove m2 mass, means there are two masses m1 and m2. I remove this mass m1. Then the question is find the time period and amplitude of resultant motion. This is my initial case and this is my final case. Everything I have drawn, you can take the reference of the diagram and try to do it. Do not see the diagram now. If you see the diagram, it will confuse you, know. Just do not see it. Try to do it by yourself. Okay? Now good. Okay, do it. You have 2 minutes of time. Okay, how to find the time period and how to find the amplitude? Amplitude is the point where the velocity becomes zero, isn't it? Means the length gap between. No, Riva, it's incorrect. So amplitude is the length between the point of what case? Length between the maximum velocity and minimum velocity, isn't it? Hmm. Did you have drawn this diagram? No? I'll just draw next diagram. Means I'll just try to make it a perfect diagram. Okay. Down one is M2, upward one is M1. Okay. And this is its natural length condition. Which condition? अच्छा एक बात बताओ. This, if I just release it, the body will do its expansion, isn't it? Hmm? And the body will go somewhere. Now Riva, it is correct. Riva have done it correct. You have to do. This is my what? Natural length, isn't it? अच्छा एक बात बताओ. After this natural length, what will happen if I just release it? The body will go down or not? Okay, so both the first, just you have to think that after releasing it, what will happen? So both of the system in a combined form, means this whole system in a combined form will come down, isn't it? And where it will come over there, the, that's my okay. Means see, अच्छा एक बात बताओ. At equilibrium point, its velocity will not be equal to zero, ना? Okay, I'm considering a point where its velocity is zero. ठीक है. देखो हम बॉडी को क्या कर रहे हैं, रिमूव कर रहे हैं ना. पहली बात समझो, क्वेश्चन को समझो कैसे बनाना है. पहली बात तो कि ये जो सिस्टम है बेटा, इस सिस्टम के अंदर दो ब्लॉक्स रखे हुए हैं. दैट मींस टू ब्लॉक्स आर केप्ट ओवर हियर. नाउ दे विल एक्सपैंड, मींस द स्प्रिंग विल एक्सपैंड. ओके. नाउ we are not removing this block, we are not removing this m1 at the equilibrium point. Okay, we are removing somewhere else. Where I'm removing where its velocity is zero. Is that clear or not? See, look over here, read the question. The system is in equilibrium and is at rest. System kaisa hai? Is in equilibrium and it is at rest. Now mass m1 is removed from m2. What I did, I removed my mass m1 from m2. Find the time period and amplitude of resultant motion. So now look over here. When its velocity will be zero, at that instant of time, means at equilibrium point, I know that the velocity is never ever zero. So I'm considering where its velocity to be zero. So let's suppose if this is my displacement, I call it as x initial. What I call it as? Is that clear? I'm calling it as x initial. So can you tell me what will be the value of x initial? Mm-hmm. Okay, in the question they are removing from the equilibrium now. Okay, okay, let us just take the equilibrium condition. That will be easier to do because the question is itself saying that I am removing from which point? Equilibrium point. ठीक है, उन्होंने स्पेसिफाई कर दिया इस क्वेश्चन में, बेसिकली दे हैव स्पेसिफाइड ओवर हियर, सो द ब्लॉक विल कम डाउन टू इक्विलिब्रियम पॉइंट, ठीक है ना, और वो ऐसे हाथ से ऐसे कुछ कुछ ना कुछ हाथ से नीचे से लगा के पकड़े हुए हैं, क्या किए हुए हैं, ऐसे समझ लो कि बस पकड़े हुए हैं, इज दैट क्लियर? So this is my M1, M2, this is M1. So initially they have this X initial gap, isn't it? Of equilibrium point. So X initial over here, if it is X initial, then what will be that? The upward spring force must be equal to mg or not. So upward spring force is how much? Kx, Kx initial, and that is equal to total mass, which is m1 plus m2 into gravity g. This mg is equal to how much? Basically, total mass you have to consider, which is m1 plus m2 into gravity g. So you got your x initial value. How much is that? m1 plus m2 into gravity g divided by how much? K. Is that clear? So at equilibrium point I have stopped it. मतलब ऐसे हाथ लगा के कुछ रोक के रखा है ना, तो वो ये जो वैल्यू है m1 plus m2 g by k, ये क्या है तुम्हारा? It is the gap between the natural length and the equilibrium point. Got it? Yes. Now what happened? You removed this mass. So you tell me from this point where the velocity was zero, suddenly a mass is removed or not? How much mass is removed? M1g is removed. How much mass is removed? So whatever the equilibrium point was over here, this equilibrium point must get shifted or not? ठीक है, तो यहाँ पर देखो, यहाँ पर m1 plus means over here it is m1 plus m2 into gravity g, upward force is spring force, this is my equilibrium point, but as I remove the mass m, the down mass which is left right now is just m2g. How much is reduced? M1g has been reduced. So then this particular length means this equilibrium will shift. This was equilibrium initial. Now this is something equilibrium. Fine. Are you able to get me or not? So let's suppose it gets shifted, and let us find out that it gets shifted by some distance, and this is my equilibrium point. Fine. The question arises: how much is this distance gap there? How much I have reduced? M1g. So the particular reduction in the spring also must be, means over, if this is my equilibrium point final, then over here also the spring force must be exactly equal to my particular m2g or not. Is that clear? So ध्यान से देखो, चलो अब अच्छे से समझते हैं। तीन चार केस मैंने इसमें है, तीन चार केस को स्टडी करना है बेसिकली, ये इतना भी आसान क्वेश्चन नहीं समझना है ना? ठीक, तो समझो, ट्राई टू अंडरस्टैंड. I'll just take a new page. See that. I'll draw using straight lines. Okay. These are just representations of spring. This is my equilibrium point initial. From where this is my natural length. How much was this gap? M1 plus M2 into gravity G divided by how much? K. After reducing the mass, this is my equilibrium point. Fine, isn't it? So over here the equilibrium point, that means the upward new spring force must be equal to the down force, which is m2g or not. So this much expansion which is there, that expansion x must be equal to how much? M2g by k. How much is that? How much is that? M2g by k. So how much I have lifted up? Just m1g by k. मेरी बात समझ में आई या नहीं है? And that's what it is drawn over here. See. So look over here. Try to understand. This was my, let us just have the recapitulation fast. This is my initial length x naught. This is my final position of x naught, it means x equilibrium, and this is the reduced length after reducing mass. How come it will be m2g right now? I told you, no? Got it? That's the biggest thing to understand actually. Okay, many people will think that this is m2z, but it is exactly equal to how much? M1z. The upward point is m2z. Okay, reduced length due to removal of mass. मेरी बात समझ में आई या नहीं है? अब ध्यान से देखो. अब तुम ही खुद सोचो. Now you think of one case. Okay, let us just take this picture. So this is my expansion from which case? uh, Natural length, isn't it? That's my equilibrium point final. How much I have reduced? By a length of m1g by k. But when it will go up, at this point, its velocity will never ever be zero, no? It will once again rise up till how much length? Only m1g by k, because all the forces are conservative. How much you provide the energy in the down, that must be conserved. Is that clear? So actually the amplitude of length is how much? Just m1g by k. Because this velocity is not equal to 0 over here. It becomes 0 at m1g by k. मेरी बातें समझ में आई या नहीं है? It's not m2g by k. So amplitude of oscillation becomes how much? Got it? But if I want to write the time period equation, what will be that? 2 pi root under which mass is oscillating? M2 is oscillating now. M2 by k. That's your answer. 2 pi root under M2 by k. Is that clear or not? मजा आया? तो हरदम हरदम ये ट्रिक याद कर लो that if this is kind of vertical case is there, so amplitude is exactly equal to removed mass or added mass into g divided by k, while the time period is 2 pi root under present mass divided by k. Got it? Okay, let us just try based upon this one more question. Then we'll move ahead. Okay, try this. What it is saying? This time, previous one was a removal of mass. This time it is a addition of mass. Think. It's not that simple. Think. It was dropped with some kind of a velocity. It's not just put it directly. See the question. A block of mass m2 is in equilibrium. If it would have been directly added, then the question would have been different. Okay. But here I'm dropping this mass with some kind of velocity. That's the biggest point. Solve it fast. Achha, I'll tell you one trick to do it. If you feel the difficulty in doing this kind of problem, basically you can convert this whole system into a horizontal line, just like previous case. Okay, ठीक. तो अगर देखो मान लो एक ट्रिक बता रहा हूँ. मान लो ये ब्लॉक पहले क्या था? m1 प्लस m2 था, है ना? ठीक. No, no, means I'm talking about the previous question. Okay. So the initial expansion, just consider, you know that this is my equilibrium point initial. That you just calculated m1 plus m2 g by k, isn't it? Now you removed the mass. What you did? You remove the mass. So here it was velocity to be 0. As I remove it, because here the force was m1 plus m2 into gravity g. Now when I remove the mass m1, the force left is m2g. So backfire will happen. Backfire makes the equilibrium point shifted, and this will get, means the new equilibrium point will be equal to the spring force where it just balances m2g. ठीक है, तो ये जो लेंथ x क्या हो गया, m2g by k. Are you able to get me or not? So what I'm left with m1g by k. ठीक है, तो जो ऑसिलेशन हो गया यहाँ पे, तो इक्विलिब्रियम पॉइंट आ गया ना, तो ऑसिलेशन कहाँ से कहाँ के बीच में होगा, यहाँ से जब जीरो है तो यहाँ पे वेलोसिटी मैक्सिमम हो जाएगी, है ना, और फिर ऑसिलेशन सिर्फ कहाँ पर होगा, m1g by k के रिस्पेक्ट में होगा, है ना, बस बात खत्म. दैट्स योर एम्पलीट्यूड. सिमिलरली टू दिस क्वेश्चन, अच्छा देखो, पहला काम क्या है कि इक्विलिब्रियम पॉइंट को फाइंड आउट करना बोल रहा है, इज इन इक्विलिब्रियम एंड इट इज एट रेस्ट. सो इक्विलिब्रियम कहीं ना कहीं पॉइंट पे होगा ना, तो मान लो m2 is in equilibrium, but it is saying the block m2 is in equilibrium, where it is at equilibrium, where x naught is equal to m2g by k. ठीक है, कैसे लाया वो ड्रॉ कर देता हूँ. दिस इज माई डाउन फोर्स, दिस इज माई स्प्रिंग फोर्स. So for equilibrium point, spring force must be equal to m2g. That means kx naught must be equal to m2g, and x naught बराबर how much, m2g by k. So you got this length m2g by k. Is that clear? Now this block started with initial velocity u. It comes and sticks to this mass, isn't it? Once again, it's an inelastic collision. It will have a different velocity. So between this and this phase, I can apply energy conservation. What will be that? m1u plus m2 into 0 must be equal to m1 plus m2 into velocity v. So did you got your velocity, final velocity or not? How much is that? m1u by m1 plus m2 into m1 plus m2. Are you able to get me? Now I told you, follow the horizontal rule trick. Just do this horizontal case for that. Okay. Just consider this as a natural length. This point directly as natural length. Got it or not? Because there is no use of natural length after that. Okay. Initial expansion was how much? There are 2 points. Okay. Initial expansion was of how much, guys? m2g by k. Are you able to get me or not? After addition of mass, what happens? This has some velocity v or not? What will be called as amplitude, where it will happen only where after some displacement where its velocity becomes how much, 0. That will be called as amplitude. So the question starts, what is this displacement or not? Yes. So ध्यान से एक बात बताओ, अगर इस इक्विलिब्रियम पॉइंट पे रेस्ट पर है, इस इक्विलिब्रियम पॉइंट पर कैसा है, वेलोसिटी इसकी कैसी है, रेस्ट. तो जो भी दूसरा इक्विलिब्रियम पॉइंट आएगा, जो भी दूसरा इक्विलिब्रियम पॉइंट आएगा उसको हम क्या मानेंगे, यहाँ पर वेलोसिटी क्या हो जाएगी उसकी, 0 मान सकते हैं क्या, मतलब हम एक ऐसा पॉइंट मान रहे हैं जहां पर उसकी वेलोसिटी कैसी है बेटा, 0. इज दैट क्लियर और नॉट? So where this velocity will be 0, where this spring force must balance is my m1 plus m2 into gravity g. Okay, is that clear or not? So the new equilibrium point is this point. 1 minute. Can we say? Hmm, uh, yeah, we can say like that. This is my new equilibrium point. Is that clear? but it has a velocity to be equal to how much? 0. ठीक, तो ध्यान से तो क्या आएगा यहाँ पे, what will be my spring force now? K original was x naught, now consider this to be x1, so K x naught plus x1 must be equal to m1 plus m2 into gravity z. Is that clear? Now what is kx naught m2g? So you got your x1 value, x1 must be equal to how much? m1g by k or not. So you got x, how much is that? m1g by k. Is that clear or not? Are you able to get me? Okay, so basically you got m2g by k and that x as how much? m1g by k. Is that clear? Okay, definitely I'll explain it once again. Okay, ध्यान से. Okay, I'll take a new tab, then I'll draw it. समझना जरा अच्छे से. Spring block mass m1 is there. Okay, that's my condition of natural length, है ना? Sorry, m2 they have kept it, m2. This is the condition of natural length. Block expands, this spring expands, comes over here. Okay, and that is my initial expansion, but this is a point of equilibrium point. Which point? But with the velocity to be equal to how much? Is that clear? Take. So here, this, let's suppose the expansion is how much? X naught. How much is that? So can I write kx naught equal to m2g? x naught की वैल्यू क्या आई फिर? m2g by k. अब तुमने यहाँ पर एक इसके इस टाइम पे एक अनदर मास m1 लिया जिसको वेलोसिटी u से गिराया. क्या चीज से? When it will collide with over here at equilibrium point, does this mass will have velocity to be 0? No, it will have a different velocity or not. So m1 plus m2 will have a different velocity. That velocity is, I found out right now, which is how much is that? Correct, m1u initial velocity. Got it? So till that point expansion was how much? X naught, which is m2g by k. Now from here what will happen? This, since there is addition of mass, so equilibrium point will shift or not? It got shifted where once again the new spring force Fs new balances my which force? m1 plus m2 into gravity g. Is that clear or not? So this spring force new means, let us call this displacement as x. So x naught plus x into k must be equal to m1 plus m2 into gravity g. So what is x? m1g by k or not? बात सिंपल है ना, जो ऐड किया मास, जो रिमूव किया मास, उसी से कम या इंक्रीज होगा. So what is that? m1g by k. Now you understood or not? Now if this was my velocity m1u by m1 plus m2, and as we know that after addition means this is the value due to which here once again equilibrium point is created. Which point is created? Now if at equilibrium point, if my initial case it was 0, so here also the velocity will be equal to how much? 0. मेरी बात समझ में आई या नहीं है? Understood? So that's the condition you have to understand. That's the condition basically you have to always understand how to do the questions. Okay, so then once again if I write omega equation, so how many masses are moving? Two masses with the same spring constant, so omega square must be equal to m1 plus m2, k by m1 plus m2. Is that clear? Riva, are you able to understand? Okay. And what will be your amplitude of oscillation? Mm-hmm. Mm, should we consider over here velocity to be zero? That's the biggest point. यहाँ पर velocity हम zero माने क्या? चेक कर लेते हैं, है ना? जीरो है या नहीं? मान लो, अगर ठीक है, अगर देख लेते हैं अगर जीरो है या नहीं, है ना? जनरली तो नहीं होना चाहिए, वी मैक्स होना चाहिए, है ना? लेट अस चेक। अच्छा ध्यान से देखो, तो यहाँ पर वेलोसिटी कितनी है? दिस वेलोसिटी इज m1 u by m1 plus m2. I want to find the velocity over here. Displacement is how much? m1 g by k. So between this point and this point, can I apply energy conservation or not? Consider this velocity to be v dash. Okay. अच्छा एक बात बताओ, if I can find the total energy, if I can find the amplitude of oscillation, basically I can get the value of this v dash whether it is zero or not. So let us just find the amplitude of oscillation. Okay. So what is the formula? V is equal to omega root under a square minus x square. Is that clear? V is what right now? m1 u by m1 plus m2. Omega is how much? Right now we calculated. Omega square is something like that. So it will be root under k by m1 plus m2. Root under amplitude square minus how much displacement this particle is doing? m1g by k. ध्यान से देखो. So just I can transfer this square root over there, and what it will become? m1u m1 square u square mm, v is equal to omega m1 square u square divided by m1 plus m2 whole square is equal to k m1 plus m2 into root under a square minus m1g by k. Sorry, square root will be removed. Sorry. A square minus x square. इसका square होगा ना? Root under a square minus m1g by. Why am I writing root every time? So if I just send root over there, it will be just a square minus m1g by k ka whole square. Is that clear or not? This and this got cancelled. What I'm left with? m1 square u square by k is equal to a square minus m1 square g square by k square. Are you able to get me? Yes, it's not zero over there. So amplitude is how much? Root under. Oh my goodness, what a equation. It is m1 square common u square plus g square. ठीक है, u square plus g square. If m1 square by k is common, u square plus g square divided by k. Got it or not? That's my amplitude. Okay, you guys were correct. Over here the velocity is not zero. My assumption is wrong. Here velocity is not zero. Are you able to get me or not? Yeah. Is that clear? That's a good approximation. So here the amplitude of oscillation is not m1g by k. What is my amplitude of oscillation? Root under m1 square by k into u square plus g square by k. Are you able to get me or not? Why it happened actually? अब ध्यान से समझो ऐसा क्यों हुआ. अगर हमने इसको सिर्फ ऐसे यहाँ पर रख दिया होता ना, if I would have just placed it, then what would have happened? This amplitude would have been just m1g by k. But what actually happened? You see over here, when you are dropping from some velocity, you are transferring some extra energy or not? And before the class itself, I told you amplitude is a function of energy. Amplitude is a function of what? More energy will you will provide, more will be my amplitude of oscillation or not. So that's what we got. So now you got the idea or not? What you have to do? First, write the equilibrium point equation. Then find, means if you write the equilibrium point equation, then find the shift in the equilibrium point. And if there is no extra energy transfer, the shift in the equilibrium point is my amplitude. But if there is an extra energy transfer, you have to find the amplitude using the formula V is equal to omega root under a square minus x square. Is that clear or not? Yeah, there is a transfer energy. Now look over here. I'll just do that question for you. Means just putting the value. मतलब मान लो एक स्प्रिंग है ना. अब कॉन्सेप्ट समझ में आ जाएगा. मान लो एक स्प्रिंग है, ब्लॉक है, मास m1, ठीक. तो अभी ये इक्विलिब्रियम पॉइंट पर है और इसकी वेलोसिटी क्या है? 0. इसके ऊपर तुम क्या कर रहे हो? ब्लॉक को रख दे रहे हो. क्या कर रहे हो? ब्लॉक m2. पूछ दिया फाइंड द एम्पलीट्यूड ऑफ ऑसिलेशन और समथिंग लाइक दैट, या एक्सपेंशन जो भी कर. तो ध्यान से देखो, तो इनिशियल एक्सपेंशन कितना होगा इसका? पहले तो इनिशियल एक्सपेंशन होगा ना. बॉडी कहां पर जाएगी? पहले बेसिकली m1 खुद एक इनिशियल एक्सपेंशन पर होगा. मींस दिस m1 विल बी एट सम एक्सपेंडेड लेंथ. ओके, दिस इज माय m1g, दिस इज m1. सो इनिशियल एक्सपेंशन फ्रॉम द नेचुरल लेंथ, मान लो ये नेचुरल लेंथ है ना. So let us just call this as x naught. I have drawn this as wrong, but okay, it's not of use. So x naught is equal to how much? m1g by k. That's my equilibrium point. Now the equilibrium point will be shifted. Now the blocks are how many? 2, m1 plus m2. So the down force is how much? m1 plus m2 into gravity g. So this x, if you will find out, it will come as definitely m1g by k or not. Sorry, m2g by k or not. The mass which is put it, because this length was how much? m1g by k, and total length should be m1 plus m2g by k. Are you able to get me or not? अब यहां पर इसकी वेलोसिटी क्या थी? यहां पर तो वेलोसिटी 0 है ना. मींस इनिशियली इट्स वेलोसिटी वाज 0 और not. When you when it is at equilibrium point, means already it's said as a condition now that at the equilibrium point my velocity is 0. देखो तो क्वेश्चन में ही तो लिखा, द ब्लॉक मास m2 is at equilibrium and at rest. समझ में आई बात? तो ये इस पॉइंट पे कैसा है? जीरो वेलोसिटी के साथ. आर यू एबल टू गेट मी? तो अगर मान लो, अगर मैंने इसको एक्सपैंड कर दी, कुछ लेंथ से एक्सपैंड किया, कितने लेंथ से एक्सपैंड किया? बेसिकली m2g है ना. तो बेसिकली अगर ध्यान से देखा जाए तो ये अगर इक्विलिब्रियम पॉइंट नया वाला बना, तो यहाँ पर इसकी वेलोसिटी कैसे हो जाएगी? मैक्सिमम वेलोसिटी होगी ना, है कि नहीं? क्योंकि डोमिनेटिंग फोर्स, विच इज माय डोमिनेटिंग फोर्स? m1 plus m2g. So the मतलब what we have to take into consideration is whatever is my initial condition will not be the same equilibrium condition for the next case. Is that clear? So the amplitude must be from the V0 to Vmax. What is that? Root, and basically it is m2g by k. So it just appeared as m2g by k or not? Understood or not totally? पहला इक्विलिब्रियम पॉइंट हमने हाथ लगा के रखा हुआ है, दूसरी बार में तो हाथ नहीं लगा के रखेंगे ना. सेकंड टाइम आई विल नॉट पुट माय हैंड ओवर देयर और नॉट. सो हियर इट विल बी Vmax. Got it or not? Similarly, in that previous question, now you got the idea of how actually is happening. M2 was there. This is my initial equilibrium point where velocity is 0. Got it or not? But look over there. When it comes over here, is its velocity 0? No, it's V max basically, isn't it? So what is my amplitude? M1g by k. Understood? Got it totally? And you can prove it. You can even prove this, that this velocity become V max over there. How? Apply the energy conservation. That's all. Is that clear or not? Riva, is this clear now? ठीक है, आगे बढ़ा जाए. You wanna try one more question? ठीक, चलो अब बताओ. हाँ, torture of mind. Find the maximum amplitude of 2m such that The mass m does not lift up from the ground. Hmm. Think. Did you guys got the idea of these two questions or not? First equilibrium point is 0 by putting a hand. Next time it is not 0. It has a V max. Got it or not? So the amplitude is 0 between two equilibrium points. Okay. Similarly over here, that's what is this question is happening. Here, as it is getting collided, I got the velocity. Extra velocity is provided. Means at that equilibrium point itself, I got the velocity. But over here, the velocity will not be 0. But this expansion will be definitely how much m1g by k. So now, if this velocity is not 0, we can't say that this is my amplitude. This is not equal to amplitude. So what is my amplitude basically? So if we know my x, and if I know the velocity initial, then I can know the amplitude or not. If I know my x, what is my expansion? Okay, then I can definitely know my amplitude. Is that clear or not? This by putting that particular relation. Okay, ठीक मजा आया बताओ अब ये क्वेश्चन बनाओ horizontal case of collision will be very easy but the vertical case will be little bit hard okay so you have to focus on vertical case try to solve all these questions one more time pick it up I'll share the pdf and try to solve it one more time then you'll get the answers okay सोचो ऐड करना है नहीं करना अच्छा पहले तो ये 2m will compress the spring or not yeah, the downward force is 2mg so what is my compression at the point of compression spring force will be equal to 2 mg so this becomes how much x naught बराबर 2 mg by k got it ठीक है x naught बराबर कितना आया 2 mg by k अच्छा एक बात बताओ सोचो जरा आफ्टर दिस compression means over here this is a point of equilibrium word or not this is a point of which case equilibrium or not so from here is my velocity will be zero no it will be maximum velocity after that once again the velocity will be zero is that clear so मतलब हम कंसिडर कर रहे हैं कि let us just consider for the case of equilibrium point mean point that x naught is equal to 2 mg by k अब ध्यान से सोचो जरा होगा क्या इसके बाद तुम बताओगे मैं नहीं कुछ कर रहा ठीक है let us just draw 2 or 3 diagrams Sorry. Okay, this was my natural length. This is compressed case. From here to here, this length has become x naught is equal to 2 mg by k. ठीक है ना? अच्छा, this point will be called as mean point or equilibrium point. Is that clear? After that, what happens? Can you tell me? Let us just interact. Then we can only say. Thing. अच्छा, means we know that this velocity is not equal to zero. Let's just remove the concept. अच्छा, एक बात बताओ. From this point, if this mass wants to lift up, this mass wants to lift up. So ध्यान से सोचो जरा. If this is mg, the downward force for this mass is how much? mg. अच्छा, spring constant is k. Spring constant is how much? k. So if the particular body wants to lift up, then this spring force for the mass m, spring force for which a small m must be greater than mg. Then only the particular mass m will be lifted or not. Whatever happens means this will get compressed till over here. We don't care a shit about that. But we know that if this mass wants to lift up, then the particular length, the particular spring force must be greater than mg. Now this spring force, let us consider that whatever is my means what is the amount of displacement we require from the downward position. Let us consider that to be k into x. Spring force will be how much? Kx dash I call it. Then kx dash must be equal to greater than or equal to mg. So x dash I got how much? Mg by k. Means from the down point the spring must be lifted by how much distance? X dash, which is how much? Mg by k. Then only the mass m will rise up. Is that clear? So अब ध्यान से देखो, पहले तो ये means this 2m will go to the mean point where its velocity will not be zero. Then once again it will rise up till over here. It will come over here. And then means what will be the process? ध्यान से देखो. 2m got compressed. This is I'll draw the condition. This is my natural length. ठीक है. That's my whatever is there mass m, 2m, spring, natural length. After that equilibrium is attained now. Red line denotes mean point or equilibrium point. ठीक. 2m appears over here. Spring, mass m, sorry, this compression is 2mg by k, है ना? After that once again it will come further down. 2m will come once again further down. Spring will be further compressed. Now this spring will restore the energy. क्या करेगा? It will restore the energy, and then here its velocity will be zero and it will start rising up. It will return back to this position with once again zero velocity, non-zero velocity, and this 2m, till that nothing happens with mass m. This 2m will once again come over here or not? अरे कुछ तो बोलो. Once again it will rise up to which condition? Natural length. Are you able to get me? To lift up, this 2m must go upwards. But to lift up, at least that upward length must be x dash, which is mg by k or not. It needs to rise up how much? Mg by k. So look over there, means this 2m has a tendency, if it goes till mg by k, nothing happens to it or not. Now the initial amplitude, अगर हम ध्यान से देखें तो initial amplitude is how much? 2mg by k. But due to this m, there is an extra length which can be provided to 2 mg by k, which is how much? Total length from this mean point becomes how much? 3 mg by. If this block 2m oscillates still over here, nothing happens to it or not? Because how not? See, to what it is saying, see the question first of all. The question is saying, then find out the maximum amplitude of 2m such that the mass m does not lift up from the ground. है ना? So this to lift this mass, at least the length that should be risen if we calculated right now, that must be greater than mg by k or not. If this is mg by k, if this gets lifted by mg by k, same with same length, this upward should also lift up or not. Is that clear? So this is how much? Mg by k. So maximum amplitude becomes how much? From here to here, which is how much? 3 mg by k. Are you able to get me? So a max can be first 2 mg by k plus mg by k, which is how much? 3 mg by k. Beyond that, the mass m will lift up. Okay, is that clear? Understood. Sure. Should we solve one more question? Do it. Yes, Riva, correct. It should be added. Oh, sorry. Read the question. A block of mass m is raised on the block of same mass. Lower block is attached to the spring. Then determine the maximum amplitude of motion such that the block will remain in contact. Okay, you please. ये वाला जो वेलोसिटी का इक्वेशन निकाला है ना, अरे भाई साहब इसमें इसको थोड़ा सा इसके बाद ये वाले स्टेप सॉल्व करना तो देर इज एन एक्स्ट्रा टर्म m1 प्लस m2 ओवर हियर, इसको सॉल्व करना। ओके, ठीक है, एक बार से देख लेना। ओके, जो आएगा आंसर। ओके, ट्राई इट। रिवा इज आस्किंग, सर नेचुरल लेंथ के ऊपर ब्लॉक का एक्सेलरेशन विल बी मोर देन द अपर ब्लॉक, राइट? अच्छा एक बात बताओ। अच्छा, this block, both of the blocks will compress the spring by how much length? This is my natural length. Yeah, so this length will be how much? 2 mg by 2 mg by k. That is my mean point or not? अब एक बात सोचो यार, if the expansion means here my velocity is not equal to 0 but v max, then it will get compressed, then it will once again rise up, and once again it will go beyond that. But if the velocity is more, then only, no? So if the amplitude means if this block starts to go upward from this natural length, what will happen? The normal force on this small will m will increase or not? If it increases, then only means try to think over there. See what will happen. You have to think like that. Means it's not just thinking. So this mass m has attained over there. Now, if this mass m rises up a little bit, means let us just consider that from this natural length, if it is going to go beyond that, then this normal will increase and this contact will be left or not. So the maximum amplitude can be how much? Just 2 mg by k. Beyond that, it is not possible. Okay, 1 minute. Well, just 1 minute. Give me 1 minute. Okay.
आपण डायल केलेला नंबर सध्या व्यस्त आहे कृपया नंतर प्रयत्न करा आपके द्वारा डायल किया गया नंबर अभी
1 minute. Yes. हाँ भैया. हाँ. क्या क्या? हाँ ठीक है भैया. ठीक है. अच्छा अच्छा बस आई एम जस्ट फिनिशिंग द क्लास इन 10 minutes. हाँ बस 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 वही चल रहा है. हाँ 10 मिनट नहीं बस 5 मिनट लगेंगे. हाँ ठीक है ठीक है ठीक है मैं दे रहा हूँ. चलो सो नाउ लुक ओवर हियर. अच्छा देखो एक बात बताओ, तुम खुद सोच के एक बात बताओ अपने से कि अगर एक मिनट लेट मी जस्ट इरेज दिस. एक बात बताओ when the contact will be left beta, first of all you need to understand that this is my natural length, this is my equilibrium point. Okay, that is how much? 2 mg by k. Yes. Now when this contact will be less, when the normal becomes how much? 0. यही होता है ना कंडीशन. when the normal becomes 0, it's a contactless surface. Are you able to get me or not? एक बात बताओ, you only tell me. See, ध्यान से समझना जरा. If this mass comes over here, the downward force is 2 mg, upward is some kind of spring force. This, if this is a spring force, they are going to balance each other. Now during the upward motion, what will happen? What will happen? The 2 mg will start dominating and spring force will start going decreasing and decreasing and decreasing on. Yes. When I go up, अच्छा एक बात बताओ, here velocity is max. Here velocity will be how much? How come the velocity is 0 if there is a retardation? Velocity is in upward direction, so the force must increase in which direction? Downward direction. Got it? Got the idea that when I go up, which is decreasing, spring force is decreasing. But what effect of mass force is increasing? 2 mg effect is increasing. Yeah. What? I'll kill you. See that? अरे बाबा, you think. अच्छा एक बात बताओ, सुनो. Uh, let me just draw this in horizontal way. Okay, now you'll get that. This is my natural length. Take here from here to here. This is my main point. Velocity increases or decreases. Let us just do it in vertical way. Then only I can make you understand. Otherwise, it's not possible to do it in horizontal way. एक बात बताओ, This is my natural length point or not? The downward force is how much? 2 mg. What is my spring force downward at that time? Okay, if about from here to here, from 1 to 2, is it compressing or expanding? Expansion is happening or compression is happening? If compression happens, spring force will be in which direction? Upward direction. Now, when the block is coming till equilibrium point, which point? So from here to here, velocity was initially 0, but here velocity is maximum. So if I write the net force equation, what is that? 2 mg minus spring force. That's my net force equation or not? During which motion? From A to B. From which case? A to B. So velocity was initially how much? 0. Now it is how much? Why it happened? Because 2 mg was dominating with respect to spring force or not? Got the idea? So when it came over here, then what will happen when it goes from A to B, B to C? C is my point where the velocity once again becomes 0. कितना हो जाएगा? So now if it becomes 0 over here, this is my point C. From here to here, which force started dominating? Spring force. Then only the velocity will become 0 or not? Yes. So when the body starts to go from B to A, from which point to which point? B to A, velocity decreases from maximum to 0 or not? So the retardation basically should be in downward direction or not? Yes. So how come? That means what? Which force is dominating? 2 mg is dominating with the spring force or not? Now you got it. अब ध्यान से सुनो, यहाँ पे वेलोसिटी क्या हो गई? 0. नीचे की फोर्स क्या है बेटा? 2 mg. और इस मास m के ऊपर नॉर्मल कितना लग रहा है उस टाइम पे? m1g. अगर तुम ही खुद सोचो, मतलब अगर हम fbd ड्रॉ करें, if I just draw the fbd, this is m, this is m, so here it is 2 mg. On this mass, the normal at the natural length is m into g or not? But when you go beyond that, what will happen? On the capital M, the 2 mg plus some spring force will be added or not? So when the spring force will be added, this upward force will decrease or not? If it decreases, what will happen? The body will have the tendency to leave the contact. है ना? हमसे वही पूछ रहा है ना कि maximum amplitude बताओ till where I will not leave the contact. So till it is where? 2 mg by k. Because beyond that, what will happen? The normal will decrease. Is that clear? मजा आया? कॉन्सेप्ट समझ में आया? ठीक है? ठीक? Is this clear or not? ठीक? तो this was all over this. You try to, I'll send the PDF right now. Just try to recapitulate and do all the problems. Try to understand, and then once again we'll explain it later if there is still a problem. Okay? Okay then. ठीक है ना? तब तक के लिए टाटा बाय बाय. See you. Okay.